right, let's go ahead and get started. I am so excited to see all 10 of you here today. So I made the trip from Finland, Costa Rica. I was at the United Nations about a week ago, and now I'm here in Boston for all 10 of you. So you get my undivided attention. Well, I'm going to talk to you about this notion of not just robotics, but this collective swarm, collective artificial intelligence, as robots work together in large volume, called artificial swarm intelligence. So before that, I want to actually share with you a video of an application of robotics that's gone wrong. So let's go ahead and hit that video. Please don't do this. When I watch that video, I can't stop laughing. That is not what robotics is about. Let me walk you through a brief history of robotics. This is from 1954. His name is George Devol. And he invented the first programmable robot called Unimate, which eventually made it onto the General Motors assembly line. And by the way, you can see how excited he is about the invention of his robot Unimate on his face. He's kind of like me. Well, historically, these robots used to be handling dirty and dangerous jobs. And for good reason, they were separated from humans for safety reasons. Well, the advanced new generation of robotics is getting to a point where they're starting to work in conjunction in a collaborative fashion with humans. Matter of fact, these advanced technologies, in particular the use of AI, is starting to make these robotics friendly, human-centric, and collaborative. Matter of fact, I'm really excited about the potential of having these in my home that can actually do some of the chores so that I can actually move up from the garage back to the bedroom. And when we think about some of the gains, efficiency gains, the precision, the automation that we can get from these types of advanced robotics, it's unrivaled. And collectively, these efficiencies help increase that competitive advantage for a particular organization. Now, all these characteristics are actually completely opposite of the characteristics my kids have, my teenagers have. They're completely loud, they're inflexible, and they're always asking for more allowance. Now, in terms of reduction of operating costs, it has a potential to reduce some 10 to 15%. It's substantive. And it has a significant boost in terms of productivity with about 10 to 55% gain. If I were you, I would tell your boss 55% gain. And when you take all this into aggregate, it starts to fundamentally shift the nature of the work on the factory floor, where it's no longer just machine-enabled productivity, but it's machines working with humans to create new forms of productivity and collaboration and mobility and configurability and empowerment. Now, the robotics industry is expected to top some $67 billion according to BCG in just a few years, 2025. And when we look at the broader supersets of automation technologies, that increases, that balloons to some $8 trillion just in the US alone. It's significant. Speaking of heavy spenders, I'm a big heavy spender. When I go shopping, I am willing to just plop down $8 whole on my purchases. Now, most of you know that China is the largest robotics market. But when it comes to density, South Korea beats all the countries. And that might explain why my best friend in school in Korea was a robot, Wally. Now what you're seeing is a breakdown of some of the types of robots and the functions and the applications and some of the major companies that are in this space. Now, when it comes to some of the production capabilities, much of it is around handling. This is packaging, picking, placing, for example. And that accounts for about 40% of all the units installed, followed by welding in automotive and manufacturing. Now, we anticipate that the advancement of robotics in conjunction with collaborative robots is going to increase adoption of robots by 25 to 45% by 2030. And that's going to produce significant productivity across the board, and on average about 30%. And that in turn is going to lower the labor cost by 18 to 33%. All of this has a huge economic impact that could weigh somewhere between $600 billion to $1.2 trillion by 2025. So again, this is sizable. Now here's the thing though. We're moving from just advanced robots to a collection of robotics that are intelligent, that are autonomous, that are self-controlled. And what you're seeing here are unmanned drones that will be used for traffic management that is being developed by Boeing, Google, and Amazon. And speaking of, if next time your teenager acts up, you can simply strap this on him and wave goodbye and say, I'll see you in a few weeks. Now what you're seeing here is collaborative robots, or also called cobots. And they're becoming very popular, and for good reason. These are lightweight robots with high degree of precision, flexibility, and collaborative capabilities. Matter of fact, these are so popular that in Japan and Europe, they're being used on a regular basis to be able to ease the collaboration of human workers as they look for something that's safe and easy to use. Now, the reason the cobots are so popular is because instead of a mutually exclusive situation where you displace humans and replace it with robots, it is actually working together. And that's why cobots are expected to grow to some $10 billion in the next decade or so, and why Teradyne acquired a company called MIR, a leader in cobots, just recently. Now, it used to be that if you wanted to deploy large-scale robotics, you had to have a very large setup manufacturing facility. Well, that's not the case, because now these robots are smaller, more mobile, and self-contained, and safer. So it means that you can actually start to have localized, smaller footprint in terms of facilities, which is enabling microfactories, so that you're closer to your demand function, rather than having to deal with the supply chain and the cost of bringing all those goods and shipments, as well as the CapEx and OpEx. Now these are my pets, Fido and Peanuts. And what you're seeing here is really the next advancement, where physical robotics is being infused with artificial intelligence. And of course, these are from Boston Dynamics. And Boston Dynamics has been working with DARPA for some time, and they're starting to apply advanced computer vision technologies to be able to be self-aware and be able to navigate this environment and work with humans as well as other robots. Let's go ahead and hit the next video. All right, thank you. So what's really embarrassing about that is that robot is called the Atlas, and it's able to do a backflip. But I can't even do a cartwheel, so we can go ahead and round that up. Thanks. All right, so the thing that I want to talk to you about that I'm really excited about is this notion of artificial swarm intelligence. It's this notion where these machines are not acting on itself for itself only, but rather it's working in conjunction, in collaboration with each other to enact something bigger, a collective behavior emergent that is able to affect things on a larger scale. Now, if you were to create a multi-purpose robot, it would be very expensive, like the one that NASA is using, right, to send to interplanetary exploration. But with these types of technologies, you actually lower the cost structure and the size of the individual robots, but yet as a collective, they're able to perform more complex, more advanced, and highly adaptive use cases that we can't even begin to imagine. Now, the largest swarm robotics demonstration was performed by Harvard not too long ago, and it was just about 1,000 of these miniature robots. And you can see that they were completely autonomous. And by simply giving them an image of a star or the letter K, it would self-organize itself and resemble that image. I call it the next evolution of text messaging, just slower, but easier to read. Now, when it comes to swarm robotics and operations, one of the key components is communication. And you can see that it is in constant feedback cycle. You can see some of the lights flickering. And based on that, it is determining the interaction with each other and as a collective. Now, the individual robots is fairly simple, but as a collective, the intelligence of the system is incredibly bright. Now, the other thing that I want to just point out is that the communication is happening through something called stigmergy. Stigmergy is a process by when you communicate through the change in the environment. So let me give you an example. In ants and termites, for example, the way they actually communicate as to where's the best foraging places is not by broadcasting all that information to all the ants and termites, but rather they change the environment by placing specific pheromones on a path so that other ants can say that is the best path to being able to identify a food source. Now similarly here it's using stigmergy, and there are many different standards and protocols that it uses as well, including use of Wi-Fi, Bluetooth, wireless LAN, as well as infrared LED lights. But ultimately what's happening is it's communicating through messages. So let's watch this video and I'll explain the rest. So it's sending these message packets, and there are various different types of messages, content messages that it communicates. And individually, again, they're fairly simple, but it's able to execute on a larger task when it's grouped together with others to execute. Here it's following the shape patterns, you can see that, and the colors indicate what it's communicating from a messaging. All right. Now, a great example from an industrial application is probably this. This is an Amazon warehouse where they're using these warehouse robotics to be able to do things that is incredible from efficiency and skill. So let's go ahead and play that video. Stop there. And what's really interesting about this is that the way they operate is through a set of rules and localized interactions. So basically, without a global model, without a central authority, it's able to basically enact all of these things using an intelligent set of protocol routing. Now, it's not just industrial applications that we're starting to see swarm intelligence. It's also being applied in the military. So in this case, what you're seeing here is that the US naval forces have experimented with autonomous boats that can actually maneuver and not only defend, but also take offensive maneuvering as well. So let's take a look at this.
A swarm of autonomous boats that will automate ship self-defense and be able to deter, damage, or destroy an enemy threat, giving added protection to sailors and Marines in harm's way.
When we look at autonomous swarm, we're not talking about a single vessel, we're talking about multiple vessels that can be in a defensive posture, and then when called upon, then can become offensive, surround an adversary, let them know that you are coming no closer to our ship. But of course, if an adversary threat decides to come closer, we can give them another warning, or potentially we can say, you've come too close, we're now going to destroy your vessel.
All right, great, thank you. And the Pentagon has also experimented with autonomous drones. So these are a pair of Hornet fighters. And what they did was they actually opened up and released about 103 of these tiny unmanned drone vehicles. And they were specifically tasked with autonomous surveillance, plume tracking, as well as reconnaissance in a highly tight, compact formation that you see here. In addition, TARPA recently announced the second half of their sprint for a project for swarm-enabled tactics program. And the objective is to be able to obtain new ideas around sensors and softwares and hardware that can increase the autonomy and the coordination of these swarm robotics. And their objective is going to be to use about 50 of these independent drones to work collectively together to isolate a particular urban objective in less than half an hour. Now you're probably thinking, when we have all of these different units or nodes of machines, one of the things that becomes really highly important is security. And this is where blockchain comes into the picture. Because imagine that you have literally drones. So for example, when I was in Czech Republic visiting one of the technical universities there, they were showing a simulation of AI where they were commissioned by FAA to be able to have as many autonomous drones flying next to flight patterns without actually getting in the way. And imagine if something went wrong, something was hijacked. What it could do, those drones could potentially collide into a commercial airplane. So the probability, if it's not secured and locked down, is catastrophic. And that's why blockchain becomes so important in terms of providing a way to have trusted communication between machine to machine. Now, blockchain is actually being experimented right now as we speak. Matter of fact, they are actually experimenting with combining mesh networks with cryptographic algorithms to be able to actually create that highly secure, highly trusted set of protocols between these potentially even heterogeneous devices and nodes. Now, this is incredibly important because if you know much about blockchain, it's about hash functions. Now, for those of you that are physicists or that have studied hash functions, the probability of hash collision is very unlikely that the uniqueness may be compromised. So in effect, what you're doing is you're making sure that you can always identify that unique machine to the unique message, to the unique transaction for that particular permission that they have been granted with, and be able to actually have a full transactional record of what occurred and who did it. Now, I will tell you though, with all these exciting development in robotics, and particularly swarm robotics, is that there are still obstacles. One of the biggest obstacles, of course, is just technological constraints. What you're seeing here is the advancement of computer vision technologies. So that's increasing. Others are in the case of gripper technologies. Others are around connectivity, and particularly around unstructured environments. By the way, you can see here, just a side note, there are startups that are creating what they call simulated data. So in the case of autonomous vehicles, it becomes very problematic. Where, I don't know if you're aware, but Waymo has spent about $1 billion to test their autonomous fleets. So being able to actually drive these autonomous vehicles on the road to get all the scenarios and the mileage that you need for certification and validation is expensive. So what's happening is there are adversarial machine learning and new AI techniques that's being developed specifically to address this notion of testing, certification, and validation without actually putting it on the road. The other barrier to the wide adoption of robotics has to do with the investment cost. Right? For some of you who have potentially thought about investing in large-scale robotics, are concerned about the CapEx. Especially in developing nations, this is exactly why a lot of the companies choose to still stay with low-skilled labor. Fortunately, the story is changing, where the cost of robotics is expected to go down some 22% in the next few years. In addition to that, there are new paradigms that's coming up, particularly that I'm excited about is robot as a service, which means that instead of having to fork out this heavy upfront CapEx, now you can actually have robots as a service and get gains and benefits immediately rather than having to lose all that in expenditures. Now the elephant in the room, of course, is job displacement. Matter of fact, when we think about kind of the larger superset called the fourth industrial revolution that contains AI, robotics, and other exponential and horizontal capabilities, is that this particular industrial revolution that all of us are in is going to potentially displace 2 to 3 times more human workers faster than any other prior industrial revolutions. That certainly calls for concern. Now, of course, fourth industrial revolution will create new jobs, no doubt. But the net effect is that just in the US alone, 40 million people could be displaced by automation. So when you take into account the changing demographics, the hyper-automation, and the rising income inequality, it creates angst, it creates fear. And truthfully, this transition is going to be hard at an individual level as well as an organizational level. My position is that it starts with changing mindset. Let me give you some data points. HP recently announced that they're going to lay off about 5,000 workers. Citigroup, about 20,000 workers in their technology and operations over the course of the next 5 years. And McDonald's haven't even announced the exact number of people they're going to terminate, but it's expected to be large. As a side note, by the way, when I was in Europe last year, I saw this sign walking past McDonald's and had a picture of chicken nuggets. And it said, chicken nuggets, now served with real chicken. So my question is, what was it before? So all of this is creating incredible fear, and that fear in turn is immobilized and gripping us. And it doesn't help that he's wearing red glasses. Let me tell you some specific examples as an analogy. In the retail sector, in 2018 as well as in 2017, look at all the store closures. They cannot keep up with the retail destruction fast enough. There is billions that are being destroyed as we speak. Now, Amazon has been around for 24 years, yet the retail industry, gripped with fear, have been immobilized and stuck. So not only are they finally losing their jobs, but the companies and the investors are losing billions. And it's just literally just evaporating from a market capitalization. Now, for some of you in different industries, you're facing incredible pressure on the margins. Look at this. Some are negative, some are not even single digit, barely 1%. And what's happening is that your CEOs are accountable to the shareholders, and Wall Street and investors are expecting your organizations to become leaner. And part of that means higher levels of automation. It's very natural to want to resist, push back. But the reality is this problem is not going away. The fourth industrial revolution is only going to speed up. Let me tell you one possible way to approach this. Like I said before, one of the ways we approach this is through a change in mindset. Cover Jones is considered the mother of the field of behavioral therapy. And her body of work has laid the groundwork for something called exposure therapy. Exposure therapy is a practice of overcoming fear by facing it head on. In a recent research, what they've done is that they've identified that by recollecting the set of neurons that stores a particular set of memories around a fear, you can start to address the underlying issue and maybe you'll solve it. You see, what happens is when we experience fear in our lives, there are these neurons that start to fire, and it creates this cluster of grouping of neurons that then stores that experience and holds onto it. And that's called reconsolidation. When we recollect a particular fear or something that bothers us, we're in effect getting in touch with that. Now, what's interesting about this study is that when we do the reconsolidation, in that point in time, there is a place and an opportunity where we can actually unlearn some of those experiences and unravel some of those fears that are holding us back. Now, part of the reason I wrote this book called Strive is that I have contributed to lots of technical publications, IEEE, and many others, but as I travel the world, and regardless of the industries and sectors, is that people cannot fundamentally bring about transformation because they are stuck. So we needed to work on the individual mindset and attitudes first. Now, Strive is about when we are actually in our comfort zone, we are in effect allowing fear and anxiety to take hold of us. And Strive says to step outside of that comfort zone to create new spheres of influence, power, and opportunities. Now, I was supposed to have a book signing, but I was told that for some reason there was some logistical issue. Apparently they didn't use blockchain, so the books didn't arrive in time. But I do encourage you to take a look. This has been endorsed by Tony Robbins, Tribeca Film Festival, and Singularity University, and Forbes as an example, and is being translated in China at Tsinghua University, in Korea at some of the universities, and just listed as one of the top 10 MBA books to read. If we are to change our organizations, it starts with us. Now let me actually leave with this final story. Raise your hand if you've seen this movie called The Hidden Figures. Great. Now in Hidden Figures, NASA was going to replace those human computers with this IBM mainframe, right? This was their slick iPhone plus back in the days, and if you wanted a selfie, you just simply sketch it on the punch cards. Well, what Dorothy Vaugh, who was a supervisor in that movie, well, in real life, as well as in the movie, she did was, it would have been a lot easier for her to kick and fight and resist and eventually get laid off, but she decided to take the bull by its horn and went to the library and studied Fortran, which is a mainframe programming language, on her own. And then did she stop there? No. She then went to transfer that knowledge of Fortran to her other human computers, so that what happened was, it was machine plus humans working together. And that's exactly what happened. So it's what happened when we choose to step outside of our comfort zone to strive. What I'm sharing with you is scary, and I haven't even shared with you some of the other exponential technologies that I cover. And it's happening. And many times after sessions like this, wherever I am in the world, I always hear a whisper after the session that says, I hope that I retire. I hope that I'm dead before this happens. But unfortunately, the reality is, this is going to happen in your lifetime, before you retire. So we can choose to chart our own course, or we can let somebody else chart it for us. So my challenge to you is strive. It's available to everyone. Thank you.